Hello students, welcome to the third lecture on the structure of the atoms. In this lecture we are going to discuss the atomic structure, atomic model given by the scientist J.J Thomson and Rutherford. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Today we are going to discuss the two basic model of the two famous scientists. Actually, when the subatomic particles has been discovered, after that there was a lots of challenge to the scientists to find out what is the orientation of these subatomic particles, how they are arranged in the atom. So in this regard, these two atomic model is very important in your syllabus to learn. Number one, that is J.J Thomson. J.J Thomson in the year 1898. So we are now going to discuss the atomic model of J.J Thomson. So in this we will be discussing the J.J Thomson atomic model and Rutherford atomic model. First we are going to discuss the J.J Thomson. J.J Thomson was a very famous scientist. He has been awarded the Nobel Prize in 1906 due to his contribution in the electric discharge through the gases. He has been awarded Nobel Prize. So, what is the select features? What is the main points in the J.J Thomson atomic model? The main points, you can write it down in your notebook. Main points in J.J Thomson's atomic model. Number one point, that he considered the atom as a spherical. Atom is spherical and its radius is 10 to the power 10 minus 10 meter. So we should make the points in the gist so that you can able to remember. Number two, he considered that all the positive charge of the So atom is spherical and its radius is 10 to the minus 10 meter. All the positive charge and the mass concentrated in the atom. All the mass concentrated in the throughout the atom. You can say this is the throughout the atom. Evenly distributed. They are basically, you can say, evenly distributed. Okay? They are evenly distributed. The negative charge of the electrons, equal numbers, we can say, equal numbers of electrons and equal numbers of proton will be there. That will going to give you a neutrality in the atom, are embedded in the atom, so that a good electrostatic stable arrangement is created in the atom. That is the three main points. 4 points that you can visualize this. This atomic structure is like this. Sphere, and this is positively charged, and here you can see the electrons. This is positively charged sphere. This is positively charged, and this is negatively charged electron. So you can understand from this model, and this model has been said as another name, that is the plum pudding model. Plum pudding model, plum pudding model, or we can say that is watermelon model. Watermelon. What this signifies? Signifies that pudding is the atom, and in this plum, is basically the electrons. And in the watermelon, you can see this is the watermelon itself is atom, and the seeds are basically the electrons. So this is a very simple atomic structure as proposed by J.J. Thomson. But this structure is not able to give explanation. Many experiments at that time being conducted. And another thing, so we can write drawbacks. Main drawbacks that there is no scientific evidence. No scientific evidence, we can say. No scientific experimental evidence. Scientific experimental evidence. Scientific experimental evidence. No scientific experimental evidence to support his idea. That is the main drawbacks. There is no scientific evidence. To support his idea of the atomic structure. This is the J.J. Thomson's model. Now we go to the Rutherford models. Rutherford and his associate want to analyze the J.J. Thomson atomic model, and they want to know the position of the electron protons. At that time, neutron was not discovered, electron protons. And for that they have made a experiment which is called the alpha particle scattering experiment. Alpha particle scattering experiment. In this experiment, you can see there is a schematic diagram. I can tell you there is a source. This is the arrangement of this alpha particle scattering experiment. There is a source of alpha particle, and it will go to the lead slit, and from the lead slit it will strike very high speed alpha particle with very high energy alpha particle, that is strike the gold foil, and gold foil having the thickness of 100 nanometer, and this gold foil is surrounded by a photographic plate, that is ZNS. Whenever there is anything deflection of the alpha particle, that will be strike at this photographic plate, and it will create a thin, very minute bright spots. So that is why this gold foil, that is this photographic plate, is there. So in this experiment, what he observed, as we can see, J.J. Thomson say that positive charge as well as the mass of the atom is evenly distributed. So if it is correct, then what is going to happen? Alpha particle will go through this gold foil, and there will be very little alpha particle that may be deflected by little amount. But experiment when conducted, he found lot of abnormalities. So what he observed, let us first write it down. He observed, number one, observation. Okay, we are writing is observation. In this thing, number one, he observed all the alpha particle go through the gold foil. Go through the gold foil. Number two, very few, we can say this is 99% alpha particle. Very few deflected. One in 20,000 alpha particle. 1 in 20,000 alpha particle. They are deflected by 180 degree. Deflected by 180 degree. And that is the most striking observation by the Rutherford. 1 in 20,000 alpha particle deflected by 180 degree. That means they do not cross the gold foil. And from this, what conclusion he made? He concluded conclusion. What he concluded? He concluded number one, all space in atom is vacant. All space in the atom is vacant. Number one, because all the alpha particles and goes on and deflecting through the gold foil. Second thing, very few deflected means very few deflected because of the repulsive force. Very few deflected because of repulsive force. Repulsive force with the alpha particle. Alpha particle is what? Now that is positively charged particle having the nucleus of the helium. Because of repulsive force of alpha particle with the positive charge of the atom. And this 1 in 20,000 deflected means the portion, this is called, this very few deflected, this is called the nucleus. What is nucleus? The nucleus is basically this place from where the alpha particle were deflected. And this nucleus, volume of the nucleus is very less, because 1 in 20,000 alpha particle has been deflected. Very less. You can say nucleus. So nucleus, volume of the nucleus is very less. This is the conclusion by Rutherford. And depending on the conclusion, he has given his atomic model. His atomic model is given, which is called also the nuclear model, or sometimes called is the planetary model, right? So what he has given, his atomic model, that we will now discuss. On the basis of the experiment, observation and conclusion, he made the Rutherford model is given by, there is two parts in this model. Number one part, that is nucleus. He say the atom has two parts. One is nucleus and other is a extra nuclear part. In the nucleus part, that is the very dense, that is the, you can say, very dense part of this atom. In the nucleus, the positive charge, total positive charge, you can say total positive charge charge and neutron, and also the mass, of the atom concentrated, and the volume of this nucleus is very, very small. You can visualize this if the radius of the atom, is 10 to the power minus 10 meter, then the nucleus having its radius of 10 to the power minus 15 meter, means it is 10 to the power 5 times lesser than the atom. Then you can easily imagine how small portion of the atom has been occupied by its nucleus. And its density, can you imagine its density of the nucleus is 10 to the power 12 gram per centimeter cube, or we can say it is 10 to the power 17 kilo per centimeter cube per cc per centimeter cube and centimeter cube. And its density, is higher than lead, 10 to the power 12 times higher. So you can imagine how in the small position the nucleus has been there. So this is the nucleus, and it is the central part, you can say central part of the atom. And second thing, that is the extra nuclear part. Second thing, the atom is extra nuclear part. In this extra nuclear part, you will find that is the vacant space, empty space of the atom. This is the empty space of the atom. Okay, this is the vacant space of the atom, and here the electron has been revolving. So you can see like this. This is the nucleus. This is positively charged, and around this nucleus there is the electron. This is the electron, it is negatively charged. So it is positively charged. This is nucleus, and this is electron, and this is orbit. So you can easily visualize this model. It resembles the solar system. This resembles the solar system. In the solar system, you can see the sun in the center and the planet as the revolving in the orbits, in the fixed orbit. So this is main part of the model, the solar model, and this is the empty space. In the empty space of the atom around the nucleus, the electron is revolving. So you can empty space of the atom, electron, you can write it, electron revolving around the nucleus, and the path where the nucleus is revolving, it is called the orbit. This is called the orbit around the nucleus, called orbit. The path is called the orbit. The path is called the orbit. And we know when there is a moving of any object in the circular path, there must be a force, it is called centrifugal force, required for this. And this centrifugal force, that is number 1 here, AB, centrifugal force, supplied by the electrostatic force of atom, by the electrostatic force of attraction. Okay, so electrostatic force of attraction with the nucleus and the electron, this is being activated. The centrifugal force is supplied by this. Okay, so we can understand this very clearly, that how the Rutherford has been given his model that is near to the solar system, and these electrons are called the planetary electrons, and this arrangement is called the planetary arrangement. This is the model given by the Rutherford, that is 2 parts, nuclear part and extra nuclear part. So, and that's resembled to the planet's solar arrangement of what we have observed in our solar arrangement. That is, at the center there is the sun, at the orbits, that is the planets. But it looks a very good model, but this has some serious drawbacks. We will now understand its drawback. Line spectrum, line hydrogen spectrum. Line hydrogen explain, I could not able to explain. Number 2, that stability of the atom. Stability of atom. If we go by this model given by the Rutherford, that electron is revolving around the nucleus, then as per Maxwell, when there is a charged particle accelerating, here when it is revolving means they are accelerating, because every time you see it is a direct changing of the direction. So it will going to emit the electromagnetic radiation, and because it is going to radiate the electromagnetic radiation, its energy will be continuously lose. It will lose the energy, and naturally its orbit will be becoming shrink and shrink and shrink, and ultimately it will collapse with the electrostatic force of attraction with the nucleus. It will collapse in the nucleus, and so the atom would not be stabilized. Atom would not be stable if we go with his statement, because it is not going to explain the Maxwell electromagnetic theory. So in this fashion, this Rutherford theory do not able to explain the stability of the atom, right? So that is the main serious drawbacks of this Rutherford, although it is a very, very breakthrough, because he has invented the nucleus. Rutherford is famous for inventing the nucleus. So this concept he has made a much improved version of the J.J Thomson. But this serious drawbacks is there in the Rutherford model, so it will not be well accepted. So this is all for today's video. In this video we have discussed all the things, that is the J.J Thomson atomic model and as well as the Rutherford atomic model. In the next we will discuss the nature of the electromagnetic radiations. Till then, all the best and be best. If you like this video, you can share with your friends. Thank you very much for watching. Thank you.